Hey everyone, welcome back to my channel. In this today's video, we are explaining about machine learning project on house price prediction, and we will train a linear regression model using a California housing dataset to predict the house prices based on the key features like income, house age, like how many years the house will be constructed, and the another circumstances like location, longitude, and the attitude. Watch till the video, like end of the video, to see how the real-time user input we will give and predict the house prices instantly. Okay, let's get into video. First of all, we have to take a new folder here. We are taking the new folder. We will create it as a linear regression. Enter, and we will go to this folder, and we have to press cmd command prompt, and then we have to go to like Visual Studio Code code dot. So it is the shortcut to like access our folder. Like I got my folder, and now I have to create a Jupyter notebook file. Suppose lm.ipynb. IPynb. So it is IPynb, the extension of Jupyter code, and then it will gives the each cell of code, so we can execute here. And now we have to import set of statements. Import numpy hash np. Sorry, enter. Actually, it's IPynb is done right. If we execute this code, then we will see. Yeah, that's why I'm getting mistake. We have to select the kernel first, and then we can execute. I think it's already done. Yeah, now I'm not getting any errors. Import pandas as pd, import matplotlib dot pyplot as pld. Okay. Um, while I'm getting these errors, okay. Now see, all the errors are gone. While executing, it will it will remove all the errors. Okay. And then from sklearn dot linear model, import linear regression. Why we are importing from sklearn? Because it only consists of all the regression models, like all the machine learning models. We have to import from sklearn only, which hold all the models. Okay, so that's why we are importing this line. And from sklearn dot datasets, uh, import fetch California housing, because it is the dataset where contains the housing prices of California. So we can directly import. We are not downloading any file from GitHub, not anything. So we are directly downloading. And then from sklearn dot metrics, import mean square error, because while after getting prediction of value, it will compare to actual values to the prediction value, and how much error, how much accuracy we are getting. That's what it will check. For the accuracy, we can get the accuracy score. That's it. It was getting like a error percentage. It was getting the accuracy percentage. Both are like some like evolutionary. Okay, and then we have to import from sklearn dot model selection, import train test split, because while we are importing a thousands of rows of data, we are dividing it into test and train. Like in the train, we will give the 80 percentage, and in the test, we will give the 20 percentage. That's it. For this, we have to import this. Okay. While executing this, I'm not getting error because all the importing sessions are imported. And now what I have to do, suppose I am giving a variable housing equals to fetch California housing, because already I given here. That's what I given here, and we have to give curly brackets, and then df equals to pd dot data frame of housing dot data. Okay, before I need to show you what is housing. If I click on this, see, I got in like a array format, all the data. And what are the column names? The column names are, see, Medink, house age, average rooms, average bedrooms, population. And I already said latitude, longitude. Based on this location wise, it will predict the values. That's what I said. Now we will convert into the a whole data table. So how we will convert? Just chill, look. I already written right this one. Uh, in this, see, housing dot data. This is the data, okay? And what are the columns? Columns equals to housing dot future values. If I'm not getting any suggestions, we will copy this. That's what I did this. Future names. And now we will do it was simply execute. And now we will see what is df. See, I got it right. I get it into tabular format. Before we will get into the like get by array format, dictionary format. And now I got it right. And now I want to add one more column in this, price equals to, and this housing dataset having a target value, housing dot target. And now I will see diff. Now the price also added, right? If you want to check, go before, and price was not there, and now it was added. Okay, now I got the like a whole table. What I have to get that whole table, I got it. And now we will do the whole coding, whatever we want. Okay, df. And now x equals to, we will split what is the target value and what are the independent values. See, these are the independent values. Already it was given, but price is the dependent value. Price was depending on all these values, right? These are the independent values, and it is independent value, and it is dependent value, right? And now we will take x equals to all the independent values, and what the value we have to predict, the y value. This is the price, and we will give df of df of we have to copy, and we don't need this average bedrooms and the population. These two rows we can neglect, and we will give the remaining. So for your sake, I'm giving in array format, comma. The second one is house age. We can drop out also, not at all issue, but I want to show you something like in array format because it will helps you. Control C, Control V, and then comma. What average bedrooms is over, and we don't need these two columns. That's why I'm giving average bedrooms, right? We need the average bedrooms, I think. But we will give. Okay. So what I have to do, average bedrooms after average occupied. I already said that these two rows we are not considering. Control C, Control V, and then comma within this latitude, longitude. That's it. Control C, longitude. Control C, Control V. That's it. And now, while I'm defining X, it will what will given? So it is showing error because I have to give in array format. Oh, hold this controls X and we will give in another array format. And now I will check. See, I got it. I got it right. X. And now what is Y? We are given the independent values. Oh, those who what are we require. That's it. And what is Y? Y is the target value. Y equals df of price. Price. That's it. And suppose if we want to print Y, then see Y values are the only prices values. That's it. We got it now. And now I already said we will split the data into 80-20 format. Okay. Now what we do if it is a 80 percentage, if it is 80% suppose, and from here it was a 20 percentage, we will take these are the x train values. Okay, these are the x test values, and it is y train and it is y test. In this way we have to take it. How we will split the data? Did you got it right? X train, comma x test, comma y train, comma y test. I got the C. Just wait. Y train, right? That's it. Now X train, Y train, no, X train, X test, Y train, Y test. That's it. Now I will given four values, but how we will give is equals to train test split. We are already imported na train test split. So that's see if we hover on this, we will get in we are getting the documentation. If I hover on this, I will get this documentation. So in this we have to give what the test side we have to give and test side right. What is the test side? 80% right. X comma y. These are the x and y values we have to give comma test underscore size right 0.2. So we are giving the test size. Test means 20 percentage and train size will be 80 percentage. And then we are giving the random state of 42. That's it. Random state we will done. Because why we are giving in the random state 42? If every time we are doing it was going into the random numbers, output will be in the random state. So we are giving the particular state like in which column we are getting. So every time the results will be the same as we expected. That's right. So that's why we are given this thing. And then model equals to in which regression we are working on linear regression, right? Linear regression. And then model dot fit of x train comma y train. That's it. And then now model is fitted. And now we have to predict the values. Y predict equals to model dot predict of y test. Actually, just wait. I think it's x test. Okay, we will do because we have to given x test values. Just a second. See, x test, right? So we have to give these values. What will be the prediction value based on this? Okay, whether it will be predicted or not, we will see. X underscore test. If I given Like this, it will give automatical suggestions, right? And then after predicting what we have to do, we have to find the mean square error. That's what we'll download na mean square error. And also we can check the accuracy, but we will check the mean square error, like how much it was getting. Mean square error. And what y underscore test, comma y underscore prediction. So control J, and now print of in f string I'm giving mean square error. In this we are giving maintain some space, and then MSC colon, we need only two decimal values, so dot 2f. So we will check, and we are getting the error percentage of 0.55. That's it. We're getting almost the prediction values, right? We are getting. So, and now what we have to do, after getting the prediction value, we will take the new inputs. From the user inputs, we will take the new inputs and we will check whether it will be getting correct output prediction or not. Okay. What we have to take from the inputs, right? Just a second. What are the what are the x values I given here? X print of x, melding. Okay. Control C, Control C. And I think I already given right here. Here I already given. I forget. Okay. So let's see. Control V. Okay. Now what I have to take? Just a second. Melding. We have to take every input. Okay. We don't need to be anyone. Language. So, and just a second. I can give alt. We can remove all this by one click. That's it. You see, right? And I want to delete this as well. See, 1, 2. That's it. And we are giving equals to. That's it. And in everywhere I'm writing same thing. I'm manipulating. We don't have to do this. We have to write on this one. Okay. Uh, Float of input input of enter the values of space, and we are given all this. We have to write each and individual melding, and then house housage. Okay. Average rooms, average rooms, heavy occupied, average occupation, latitude, and the longitude. So that's it. And after that, we are given same control V, and then we are given as values equals to np dot array, and then we have to remove all these quotations, because why I'm doing this, we are entering these values here in two dimensional array. That's it. If you can able to understand, then you can easily do it. What the what is going on here? Nothing. I think I'm getting, if I'm removing the quotations, I will set right all the things. See, now, see, now up to here there is no confusion, right? Now I'm giving the inputs from the user. The user will give the input and then it will predict the values. Okay, and now models dot predict of what the values, right? Values, and then we have to give predicted price. What this model have to predict the price, right? The what is the price we are getting, this price we have to predict. So we will give the same values and we will see. What the hell? Predict underscore price equals to, that's it. Okay. And now what we have to do, the predicted price we are getting, and print of f, the predicted output, okay, predicted output price price is in this, in here we are given what is the predict price of 0. In this 0 we are given what the thing, uh, dot 3f. Okay, we will check whether it will become or not. Okay. And before this we will give a dollar symbol because we are getting into the dollars. In California dollars only working, right? So in the form of dollars we are getting. And now we will give, if we execute this, we will give the first values, like these five values we will give, and what we have to get, we have to get this, not same value, it will get the exact value. Okay, now we will execute this. I don't know whether the output will be correct or not. 8.3252. Okay, and now it was asking house age 41.0, and then average rooms 6.984127. That's it now. Yeah, and then 2.555556. That's it. And then latitude 37.88, and then it is minus 122.23. See, these are the values I given now. Okay, and now we will check whether what will be the output. The output should be come near to 4.526. What we will like it. I'm getting the error. Built-in function method object is not subscripted. So not at all issue. Don't panic. I will. And why I'm getting this error in this eighth line, right? np dot array. So in this error we have to give the parenthesis. We have to give the parenthesis. That's it. And then we will run now. Again, I have to give the values. 8.23. No, no. We will take the second one now. 8.3014. 21.0. 6.9. No. 21.0. 6.23. Second one, right? 238137. And it was asking average occupation, right? Second one, 2.109842. 37.88. 86 or 8. I'm forgetting. Minus 122.22. Now we will unexpected the values. We will see. $33 I got. Point 630. We will see the second one. 33 point, okay, 3.585, right? 3.585. So if we given Uh, Now we have to divide this by 10. Then it will get 3.36. 3.36 by approximately we will get. Okay, right? If we multiply 0 here, we will get. So what we have to do, we have to get this by a prediction value equals to by 10 we have to do. Control C, mu equals to by 10. That's it. While I'm trying Control X, Control C, I will do here Control V. But I have to give na values. So that's it. Okay na. But we will try for your sake. 8 point. I am giving the first one because I'm easily able to see 6.984127. 2.556. 1, 2, 3, 4. Okay, another 5. I have to give. 1, 2, 3, 4, 5. Yes. And then 37.88 and 1 minus 122.23. What will I will get? $0. No, no, no. We will go follow for the old one only. Haha, right? So we are getting the values, right? Okay. Control X mu equals to control V. Yes, oh, that's it. And what we will get? Mu 2 equals to mu float of. Okay, we have to give the float value. Mu by 2. We are getting the float value, right? And we will give in the float of mu 2. We will try this, but it will take so much patience, right? We have to enter every values 8.325241.0. I'm trying, but whether I will get or not, I don't know. 4127 2 2.35 6 37.88 um minus 122.23. What we have to get the value, the first one is 4.526 and we're getting 2.0425, right? So do you getting right? What the while we are predicting much more. In the first value, how we are predicted, better getting right. And now what we have to plot, we have to make a visualization. And then PLT dot scatter scatter plot of okay y test comma y pred. These are the predicted values, right? Of color equals to green, and then label get label equals to predict predict, and then we will do the same scatter plot. Control C, Control V, time is going to happen, and we will give white text. These are the actual values, actual values, and we will see plt dot x label, y label. We don't need to give python dot um, plt dot legend, legend we have to give, and plt dot show. So while we're getting errors, see, okay, I'm given both the values blue, both the values green. Now I am given, see, these are the actual values and these are the predicted values. This is how we are getting right. So this is how the linear regression will works, and we are getting the accurate results in this. Did you able to see right? So please subscribe my channel and like the hit button, so you will get some more recommendation to your channel about the machine learning. So we will meet in the next video. Goodbye.